Hi everybody, I'm Tony E at Show IP Interface Brief, and today I was given a challenge on LAN Tamer's Discord server from one of our friends, Praveen. Praveen knows I love challenges, and when he said he had a challenge for me, I jumped at the chance. He sent me this picture and wanted to know if I had any possibilities way to solve this. So before I go any further, pause the video right here, take a look at the topology and the requirements, and see if you can figure this out. I'm not just going to walk through the solution, but I'm also going to walk through some of the ideas and the rabbit holes that I went down that were wrong. Well, right off the bat, this looked like a pretty basic topology, but I knew there must have been some gotchas in the requirements, so let's take a look. Okay, so we see we're going to have BGP here. I'm assuming BGP because of the autonomous system numbers. We see we have one prefix. Let's take a look at the requirement number one. Output for the prefix, which looks like it's originating from AS100, on AS300 should show the prefix originating from AS200. Configuration is only allowed in AS200. No network statements or redistribution is allowed. Okay, so with that, I had just about enough information I thought I could get started. There's a couple of things I knew I needed to do right off the bat, just looking at this topology before trying to meet any of these requirements. We need basic connectivity. So we already have a problem here in the topology that needs to be overcome before we can even get a prefix from here to here with any AS number. And that is the BGP split horizon rule. A BGP speaker will not advertise an IBGP route that it learned from an IBGP peer to another IBGP peer. And that's going to happen right here. As router 1 and router 2 are eBGP neighbors, router 2 and router 3 are IBGP neighbors, router 3 and router 4 are IBGP neighbors, and router 4 and router 5 are eBGP neighbors. So as the prefix gets propagated across to router 2 will take that prefix and advertise it to router 3. Router 3 will not advertise it to router 4. In an IBGP environment, which is what we have here in AS200, you need to have one of two items. You need to have full mesh or route reflectors. So in order to beat the split horizon rule for BGP, we can turn router 3 into a route reflector. And as the prefix propagates to router 2 will advertise it to router 3. Router 3, we will tell router 3 that router 4 is a client. It will advertise it to the client. Router 4 will receive it and send it to its eBGP neighbors. One of the other problems we're going to have is this prefix is going to be, the next hop value is going to be whatever IP address we assign to this interface on router 1. So router 3 is not necessarily going to know how to get to this next hop, which means we probably need to run in IGP. Could be OSPF, could be EIGRP, could be RIP, could be static routes. Another way we could have done this is to actually do a full mesh peering, even though we would be peering through each other. And what I mean here is we can have router 2 peer to router 3, router 3 peer to router 4, and router 4 peer to router 2. That will beat the split horizon rule because prefixes from router 1 will be able to be advertised over to router 4, and router 4 will send them over to router 5. So those are some of the basic problems that I saw that we need to overcome before we even begin. So I went ahead and built this topology in GNS3 and began configuring. I wanted to point out a couple of things. I did allow myself to use a network statement only on router 1. I'm using it to inject just this route. I didn't actually know where these guidelines came from or what the nature of it was. This was just my interpretation. My interpretation was that we could use a basic configuration here and here, and that our only true customized configurations was going to happen in AS200. So over on router 1, I did a basic router BGP AS100. I injected the prefix with a network statement, and I made a neighbor to R2. That's it, 3 commands. Over on router 5, I did router BGP AS300 and a neighbor statement over to router 4, and that's it, only 2 commands. I did not use a redistribute statement at all in the topology, and in nowhere else did I use a network statement. The only customized configurations were in AS200, and I'm going to show those now. Actually, before we jump into the command line, I want to point out my IP address schema, just so as we're looking through the command line, everyone can follow along. In between each of the routers, the routing schema is going to be 10.1. The two router numbers and then the router number. For example, this is going to be 10.1.12. This is going to be .1 and .2. This is going to be 10.1.23, and this is going to be .2 and .3. This is going to be 10.1.34, and this is going to be .3.4, and lastly 10.1.45. This is going to be .4 and .5. And I'm using the interface IP addresses for my BGP peers. I'm not peering via loopbacks. I'm also not using any static routes or tunneling, which is sometimes a requirement in the CCIE lab exam that I've heard a lot about, that often you cannot use static routes and you cannot use any form of tunneling to get across. Okay, so let's dive into the command line. Let's start with router 1. Here we are in GNS3. I'll go ahead and open up router 1. I'm going to do a show IP interface brief. I have our interface IP as well as the prefix, the required prefix. I have it as loopback 100. I'm going to do show run section BGP and show you the minimal configs I have here. Router BGP 100, the network statement injecting that single prefix, and our single neighbor. That's it. I don't have any other configs on router 1. I'm going to jump over to router 5 and show you the end of the line, what configs I have here. Show IP interface brief. I have only my interface IP address. Show run section BGP. I have only the router BGP autonomous system number statement and our single neighbor. So inside here on BGP AS200 is where all of the magic happens. So while I was working this lab, I was trying to think ahead on a couple of ways we can influence this path. If router 1 injects the prefix, it's always going to be the originating autonomous system number. That means when it gets all the way over here to autonomous system 300, the autonomous systems read from right to left. So it's going to have an I, because we're injecting it via a network statement. Our first autonomous system number, logically it would have 200 because we'd be going through 200, and then we would not see 300 because you don't see your own AS when you're in the autonomous system. So I was trying to figure out how we can influence this number or remove it or change it. I went down a couple of rabbit holes. Some of the things I wanted to do was I wanted to see if I could adjust using a route map. And I was wondering if I could set origin, if I could actually set the originating autonomous system number. You can't. Instead, you can only set the origin value, which specifies whether or not it's internal, external, or incomplete. AS path prepending isn't going to do us any good because we don't want to add autonomous system numbers. We want to remove an autonomous system number. So both of these are out so far. AS path filtering is also out. So I remember a couple of things that we've done many times before, which are local AS and AS override. So I thought, okay, AS override, yeah, I can do that. That makes sense. This kind of looks like where we would use AS override, which would be a service provider. A service provider example would be if you had a customer connected to a provider edge, and this customer's autonomous system number, let's say 100. The provider could be, in this case, 200, but let's say you had the customer on the same customer on the other side, and their autonomous system 100. They own that autonomous system number. It's okay if they use it on both sides. The BGP split horizon rule will actually not accept the path because it sees itself in it. So what the provider can do, the provider can actually do a AS override, which will replace this number with itself. Okay, so I thought, okay, that's perfect. That's exactly what I want to do. I want to use AS override here on router 4, and instead of 100, I just want to see it say 200 before it goes into BGP, excuse me, before it goes into autonomous system number 300. So over on router 4, if I do a show run section BGP, I have basic neighbor statements here. I have a neighbor going to router 3 and a neighbor going to router 5 neighbor statements. So let's get into our router config, router BGP 200, and let me do neighbor for router 5, and let me do a question mark, and I wanted to do AS override. So I'm looking through here, I'm looking through all the options, as I'm trying to figure out where is AS override. Now I know I've seen that before. Now it's not in here somewhere. Where is it? And I'm thinking, okay, maybe it's called override AS. Maybe it's a little further down, so it's alphabetical. So NOP, it should be in here somewhere. Nope, I don't see it anywhere. So I thought maybe I'm just using a different version of iOS or something that doesn't support it. I don't understand. Why can't I see this command? So you can do like do show version. You see I'm running 15.2.4. Not the latest, but should have this feature. This is an old feature. And I couldn't figure out why I wasn't seeing this, this command. I left that idea and I started playing around with local AS. So I started saying, you know what? I need to be able to do a local AS with a no prepend and a replace. But still, that wouldn't get me what I need by itself. That's not going to change the origin of AS100. I even thought about confederations. So I was playing around with the confederation idea, and the bottom line was I just couldn't get it. I just couldn't get the end result I was looking for. Maybe there is a way to do it, and I just didn't go down that path far enough. Instead, for my solution, I ended up using a combination of local AS with no prepend and replace, and I did it with a combination of AS override. And I'm going to show you how I use those and why I use those. I'm going to walk from left to right, from router 1 to router 2, router 3, router 4, and sort of step through this and show you how I did this and why. On router 1, we already show it's a very basic config. So if I do show IP BGP summary, I have only one neighbor. That neighbor is router 2. And router 2's autonomous system number that I'm peering with from router 1's perspective is 200. Now over on router 2, if I do show IP interface brief, I have my two interfaces facing router 1, facing router 3. If I do show IP BGP, you see I have nothing here. This is BGP is actually configured on this router. We're not seeing it because I actually have VRFs configured. So let's take a look. Show IP VRF. And you see I have my two interfaces in a VRF. So let's take a look at what that VRF config. Show run section VRF. It's a very simple config. I did nothing more than IP VRF 200 and gave it a route distinguisher of 200:200. It was only 2 lines of config. I called it, the name you give a VRF can be anything alphanumeric. I called it 200 because that's the numerical value of the autonomous system we are in. You can use a name if you choose. Okay, so how do we see our BGP neighbors when we're working inside of a VRF? We do show BGP VPN v4, unicast VRF, and in this case 200 summary. And I can see I have two peers. I'm paired with router 1 and I'm paired with router 3. Let's take a look at the router config. Router BGP, we're entering an address family for IPv4 in VRF 200. If we split this up, you see I have neighbor statement pointing to router 1, which is nothing more than remote AS100. I also have a neighbor statement pointing to router 3, which is showing as autonomous system 100 as well. You're probably asking yourself, why did he peer between router 2 and router 3 using AS100 on both sides? Let's go to the drawing board. Just like how I previously drew a basic service provider architecture where they use AS override, what I'm trying to do is use AS override here on router 2. So that means router 2, I need router 2 to think that AS100 is on its incoming side and its outgoing side. I need it to think that router 3 is actually in AS100. Okay, so how do we make router 3 pretend that it's in AS100? Here is the section of config pertinent to pointing to router 2. I gave router 3 an AS number, an arbitrary AS number. I gave it 250 in this case. It could have been any number that wasn't 100 or 200. I'm telling it to peer with router 2, and router 2 is an AS 200. And I'm telling router 3, pretend that you are autonomous system number 100. So in this case, router 2 thinks router 3 is 100, and router 3 is saying, I'm 250, but I'm going to pretend that I'm 100 for you. So what that enables us to do, it enables router 2 to see that router 3 is the same AS as the prefix it's advertising, so it can effectively do the AS override function, which is the command here on router 2, AS override. So now wait a second. We just saw that that command wasn't available, but yet here it is available. So let's take a look at what that's all about. So if I go into router BGP 200, and if I just pretend like I'm going to type a neighbor in here for router 3, and I want to do, that is AS override. So if I do AS question mark, it's unrecognized. That command isn't available under global BGP config. Instead, you have to come under an address family. Now when I type the command, it's there. Now I believe this is by design because you would use AS override typically in a service provider network. And that's also where you would see various VRFs in your BGP, is in a service provider network. I don't know if there's any other reason why it's limited to working under a VRF, or if it is just in fact a version of code that I'm using. But test it out. Try it on some other versions of code and let me know. All right, so from router 2's perspective, what router 2 is going to do is when he advertises the prefix from router 1 to router 3, he's actually going to override the first autonomous system number with himself. So it's originally tagged with 100 going to router 2. Router 2 is going to send it to router 3, but it's going to take that tag of 100 and overwrite itself onto router 3. Let's take a look at the show IP BGP on each of these. Router 1, show IP BGP. This is originating the prefix. Router 2, we're going to do show BGP VPN v4 unicast VRF 200. And we see in our AS path, it's a BGP and it has AS 100 in it. Now let's go over to router 3. We're not running any VRFs here, show IP BGP. And we can see now that this prefix has come from AS 200 and we've overwritten the originating prefix of 100. So wait, that's interesting. Why do we have this additional 200 in here? And that's because, remember, router 3 is actually running BGP 250, which is a different autonomous system than 200. So the only autonomous system numbers that are hidden from the show IP BGP command are your own. And in this case, 200 is not his own. Okay. So if router 3 is BGP 250, what is router 4? How is router 4 peering back with router 3? Let's take a look. I'm going to do a show run section BGP here on router 3. Here's our config statement for peering up with router 4. Router 4, we're telling router 4 that, hey, your remote autonomous system 200 and I'm locally known as 200. If I open up router 4's, he's peering back with router 3 as if it was remote autonomous system 200. So although router 3 is actually configured with router BGP 250, on both sides, he's pretending to be somebody else. Upstream, he's pretending to be 200, and downstream, he's pretending to be 100. And that's so router 2 can appropriately use the AS override function. Over on router 4, we see the same entries. Now router 4, there's nothing special here. We'll do show run section BGP. He's paired with router 3 and router 5. Let's go over to router 5 to validate. Show IP BGP. And you look, this AS path, the prefix is originated into BGP. This is where router 2 is doing an AS override. This would normally say 100, but router 2 is overriding that. This is router 2 to router 3, and then this is router 4 to router 5. So I don't know if this was the appropriate solution for the problem. I went down a couple of rabbit holes. I tried many different things, and ultimately this is what I came up with, using a combination of local AS with no prepend and replace, as well as AS override. From router 5's point of view, the prefix originates from AS 200. I did not use any network statements in any of the routers other than router 1 to originate the prefix. I did not use any redistribution commands throughout. I'm also not running any IGP or route reflectors. Because we are using the local AS feature here on router 3, each of these does a next hop self. So from router 2's perspective, our next hop is back to router 1. Our next hop is back to router 2. Our next hop is back to router 3. And our next hop is back to router 4. As always, guys, this was a lot of fun. I really enjoy these challenges. If anyone has any challenges they'd like to send my way, please do. You can catch me hanging out in the LAN Tamers Discord channel. You can reach me on YouTube or Twitter at Show IP Interface Brief. And if anyone has solved this any different ways or has any alternative ways of solving this, I'm really interested. You can post your solutions below. You can send me a message. I'd love to hear from you. When I asked Praveen where he got this challenge, this topology, he got it from a buddy who I believe they saw it on a Cisco Live presentation. I don't know which one just yet, but when I find out, I will put a link in the show notes below. Thanks for watching.